Hello, everybody, again. This is Mr. McAllen, and we're going to be going over questions 29 through 32 of the midterm review. Remember, anything you see here that you think may help you with the midterm, you are entitled to using a note card, I believe. And, if there's something that you think formula-wise you're going to forget, you should definitely pause the video and make a note of it now. So here we go with writing interval notation. This should be pretty easy. These are some of the first few problems we did of the year. This is basically you just want to write in set builder notation. It says to write interval such that it says x such that x is greater than 7. Well, x such that x is greater than 7 would be from 7 to infinity, and you don't want to include 7 because it's greater than 7, and you can never include infinity. So our interval in notation would be both parenthesis, and that would be choice A. Now, on the off chance that they said x such that x is greater than or equal to 7, the set builder notation would be 7 comma infinity open bracket. So that would be a different problem, but I just want to show you by contrast when you use that square bracket. So number 30 is one where we have x is a set of numbers trapped between -4 and 0. So with interval notation, it's really easy to get the interval right because you always put the lowest number first and the highest number second. And then because we have less than or equal to and less than or equal to symbols here, we're just going to use square brackets, and that would be our interval. So looking at all the choices, this would be choice D. Moving along, we have a transformation problem. Number 31 says, for a function that is finally graphed after the following transformations are applied, that means we started out with the square root of x, and these transformations were applied. We went down 4 units, so that would be root x, and then down 4 will be on the outside. It was reflected about the x-axis, so that means the negative is in front of the function, and shifted left 5 units. Okay, so then a left-to-right movement is always on the inside of the function, so I extend the function symbol, and if it's going to go left 5, then I have to put in +5, because what I want to have happen is when I set the interior of the domain equal to 0, or the domain, not the domain, but what is inside the function equal to 0, as we explained in class, and I solve for the new location of the starting point of the function, I would get x equals -5. And the only way I get to -5 is if I have +5 on the inside. So I would be looking for that function that I just constructed. And it looks like it is choice A. Let me just make sure I didn't make any mistakes, and I would put choice A for that. So looking at the next one, it says find the x and y intercepts if the function is already in factored form, and the work has already been done for us in terms of with doing any sort of factoring, thank goodness. So we have x plus 5, we have x minus 6, and we have x plus 6. So x-intercepts are the roots or zeros when you set each term equal to 0. So that's just, x plus 5 is equal to 0, x minus 6 is equal to 0, and x plus 6 is equal to 0. So I have 3 zeros, or x-intercepts, at x equals -5, x equals 6, and x equals -6. To find the y-intercepts, that's where you just plug in x equals 0, and you see what value of y you get, because a y-intercept is where you cross the y-axis, and that coordinate will always be 0 comma some number. So you've got to just plug 0 in for x and figure out what you get. So on this function here, when I find f of 0, that's going to be 0 plus 5 times 0 minus 6 times 0 plus 6, and you end up getting 5 times negative 6 times 6, which is negative 36 times 5, which is negative 180. So that would be your y-intercept. So I'm looking at answers B and D because I see the y-intercepts are negative 180, and the x-intercepts are negative 5, negative 6, and 6, and that would be choice D again. So hopefully this video has helped, and remember, any part of it that you feel you need to refresh upon, make sure you make a note of it, and hopefully you'll tune in for the last few problems, 33 through 34 and 35, if you're stuck on those, and we'll talk to you later.